Okay, so in this video, we're going to learn about variables, data types, and operators. So what is a variable? Well, a variable, it holds some value or data in memory. So think of an envelope. An envelope is used to hold or carry letters, or we can even say an envelope stores information because the letter contains some information in it, and at some future point someone is going to open the envelope and retrieve the contents inside. So with a variable, the information is usually in the form of a value or data. So for example, when I type string meal equals to Sadzane and I print also just notice that in Dutch you have to end each statement with a semicolon, unlike say in Python. But in this statement I have declared a variable called meal, and the type of this variable is a string, and that's because I use double quotes. You can also use single quotes, and the value of meal is Sadzane, and as the name variable implies, the value can change. So I can change meal to say spaghetti and meatballs. And now when I run and print, I get spaghetti and meatballs. I know, not as good as our previous meal, but that's besides the point. So this way of declaring variables, it uses type annotation because I specified the type when declaring the variable, but I could easily have typed, let me comment this out. Var meal, say, equals memory. And this var keyword for variable, it allows Dart to infer the type of the value passed. So if I hover over meal, you see it says it's of type string. So this is known as type inference. So Dart was able to know what the type for meal was without us explicitly telling it. And again, it recognizes that the value or the text, it's enclosed in double quotes, so it's a string. Let's just try another quick example. Let's say var points equal to 15 and print. Well, we don't have to print, but we didn't specify the type, but we see that this is a number or an integer. So when we hover over the variable name, we see that it says it's an int. And just as a side note, once you have assigned a variable and the type of it, you cannot change it to a different type. And this is because Dart is a type-safe language. So from our previous example, we can no longer assign meal to anything other than a string. So if I try to set meal to say 10, it's not going to work. You see, it says a value of type int can't be assigned to a variable of type string. I'll just comment this out. But we can still set it to some other string. Right, so this property where you can reassign a variable to different values, it means it's mutable. You can change it. But let's say you don't want it to change. Well, we can add the const and final keywords to our variables or declarations. So if I say const double rate equal to 12.5, now if I try to set rate to say another double, I don't know, you see we have a problem here. It says constant variables can be assigned a value. So it's also the same thing with final. Say final int, I don't know, cars or something, equal 12. And if I try to reassign cars to any other value, we see again we have a problem. The final variable cars can only be set once. So by using const and final, you're making your data immutable. It cannot be changed. And on the other end of the spectrum, there is a type called dynamic, and if you set your variable to be dynamic, then that means you can change it to any type. For now, let's comment this out. So let's declare some dynamic variable, and let's set fruits to 5, and this works. And say this works too. I can even reassign it, say this time to a list of fruits. Avocado. And this all works just fine because I had set it to dynamic. You won't get any warning, and this isn't highly recommended just because it can get confusing. So it's best to stick to having your variables have a specific type. Now say you want to convert a variable to a certain type. Let's just create some variables. And let's have another number, say 7.5. And for some reason you want to change the value of some number, which is an int, to another number, which is a double, but you want to have it as an int. So you can convert the type using toInt like this. Now we print so when we print, we see that we get 7, and we've changed the double to an int. So we've seen quite a few types already. Let's just list them here. For now, I'm going to delete this code just so I have space. So we have number, integer, decimal numbers, which are doubles, strings Boolean for true or false values, and we store dynamic. And later on, we'll take a look at other types like lists, sets, and maps, and even get to create our own types. But for now, let's just quickly go down the list of these types we have here and just take a closer look at each of them. So for num, let's create a variable, say, and let's set it to some value, and we print but since numbers can be integers or decimal point numbers, we can set our number to a double, say number equals 0.057 or something, print. Got a semicolon. And so we see 0.057 also gets printed. So num can hold both integers and doubles, but of course we've already seen you can specify the type. So here, let me just, okay, I'm getting confused. Int, I don't know, let's say age or something, equal, actually, let's just comment this out. We have int number equals 13, double other number equal to, and we know this will just give us our values. Right, of course, and we have our values. And because Dot is an object-oriented program, you can also do things like rounding up a number. So say we want to round up our double, it rounds it to a whole number, but say we want to round it up to 2 decimal places, so we can type right, we've set it to 2 decimal places. You can even find out if a number is even or odd by typing, say for the number we have, and it returns a Boolean value of false, of course, because number is not even. A Boolean value is a binary value, which means there are only 2 possible values, either true or false. We can also say either 1 or 0. So if we're to explicitly create a Boolean value, for now let's just comment this out. Say const ichokwadi equal to true, const manye equal to false, and we print so it means true in my language, and manyepo means lies, so that's a free Shona lesson for you right there. But I mean, that's about it for Booleans really for now. We'll get back to them when we're using logical operators and getting into control flow. So now moving on to strings. So far the string variables that we've created have been single line variables. So something like, okay, let's first get rid of this. I could say string last name equal to Mokombe. That's the name of my favorite singer. But if you want to have the string on multiple lines, you can use the escape character. So say var haiku equal ha ha ha. Did you hear that? That was the sound of my laugh. So now we print so we see it's on multiple lines, and you can also use triple quotations to write multi-line strings. So let's create another variable. Let's say const on low equal so when you low, do you really laugh out loud? Or do you just low? Okay, let's print that. So we also get it on multiple lines. Now, what if you want to join strings or any values or expressions for that matter and print them out? This is where concatenation comes in. So say we want to type out or use the example above. Say we want to have Mukudze Mukombe is 34 or something years old. And we already have the name and last name, so let's just quickly create the age. And now we print name, last name is age or something years old. Oh, I forgot to put this in quotes. Okay. So we get Mukudze Mukombe is 34 or something years old. So the $sign is a way to differentiate just regular text from an actual value that is going to be printed inside the quotes. And it's not just variables. You can concatenate, you can add expressions and even calculations. So say we want to have the name show up as being all caps, so we can call the method to uppercase. And for now, you don't have to worry about what a method is. That will be for later, but to uppercase. And just for the heck of it, let's just 10 plus 24. And that's kind of silly, but just so you see, instead of passing age, we can just calculate it. And so now when we run, the name shows up in all caps, and we still have our age as 34. So up until now, we have covered variables and data types. And now let's move on to looking at operators. So like any other programming language, you can perform simple and complex arithmetic operations in Dot. So the simple arithmetic operations we can perform on numbers are, let me give myself some space. So operators, we have addition, subtraction, multiplication, and division. So let's just create some variables for us to play around with. Const, say, I don't know, Shiba. And this is in no way any endorsement of anything. And we're gonna print values. We're gonna print the value for, say, Shiba plus, say, dot. And of course, we expect to get 180. And we can subtract, get 20. And actually, let's set a separate variable for the result. And we've done addition and subtraction, so let's multiply Shiba with the price. And now we're gonna print the result. And for completeness, we can divide. Now, if you want to do integer division, then you can use the squiggly / operator. I think the official name, it's truncating division operator. Truncating, yeah. It's like that. And so let's say we want to do integer division on, I don't know, 11 and 2. So we get 5. So we use this operator to calculate how many times a number goes into another. So the other operator that calculates just the remainder, it's called the Euclidean modulo operator. Euclidean. I don't know if it's modulo or modulus. Anyway, operator, which is the percent sign. So for this, let's say we just want to find the remainder. We know 2 goes into 11 5 times, remainder 1, which is what we get. So we've gone over these operators, but what happens when you use multiple of them? And so you have an expression like, say, 9 plus 6 divided by 3. So what's the result going to be? Is it going to be 5 or 11? Well, I don't remember which grade they teach you this in, but we used to use the acronym BODMAS to remember what the execution order is when you have multiple operators. And of course, BODMAS stands for bracket of division, multiplication, and addition and subtraction. So that's exactly what dot uses for the operator precedence. So here we'll first divide 6 by 3 and then add to 9. So we expect to get a result of 11, which is what we get. And if we had put brackets here, and we know brackets get first precedence, so now we have 15 divided by 3, which will give us 5. Right. You can also import the .math library, which gives you access to a variety of math functions. So at the top of your file, you can add .math, and there are a variety of functions you can use from the library. So you can find the square root of a number, 9, and you can compare two values to find the minimum or the maximum. So let's do min 3, 9, and now let's find the maximum of some numbers, say 1 over the square root of 2. Why do I need to put this in brackets? And say sine 45. This needs to be in radians. So we get the square root of 9 as 3, and the minimum value, of course, it's -3, and we get the max between these two values. So if you want, you can play around and see what other calculations you can do. Now, the last operators we will look at are the equality and relational operators. The last operators we will look at are equality and relational operators. So we have the double equal sign, we have the greater than sign, less than, greater or equal to, less than or equal to, and not equal to. So we'll mostly use these when we get into conditional or if-else statements. But let's just take a quick look first at the double equal sign. And the double equal sign is different from the single equal sign we've been using. It compares two values versus assigning them, like what the single equal sign does. And in fact, we can actually create a variable like so. Let's print check. So what do you think the value is going to be? Well, what we're essentially doing is evaluating this comparison and then assigning the value to check. And what are the possible values? Well, this statement, it can either be true or false. So a Boolean value will be returned, and you can see that check has already been assigned the bool type. And we know, in this case, we know 4 is not equal to 3, so we're going to get false. We can, of course, if I change this to not equal, then we get true, or I can do something like not this. Oh, I put 1. And we get true. So this is saying not false, and not false, it's true, which is what we got. And of course you can play around and use all the different signs. I won't get too much into that for now, but actually before I had used, when I was showing the max value, those values, they're actually equal. I don't know if you had caught that, and we can confirm that. So this, oh, I don't need the max. So I'll check. Equal to, so we should get true. Oh, we're getting false. Let's see, let's print. Zero. Oh, okay, it's a rounding thing. So you see here, sine of 45, it's this, and it ends with 6, and 1 over square root of 2. So it's just a rounding. It's because of the rounding, but they're the same value. So it's kind of supposed to be true, but anyway. But yeah, that's it for now. That was it for this video. Okay, so in this video we have learned about variables, different data types in Dot, and we've dabbed a little bit into arithmetic operators as well as equality and relational operators. If you've made it this far into the video, thank you, and we're just getting started on our journey to learning Dot and ultimately start building our own cool applications using Flutter. So I hope you continue moving forward with me, and I'll see you in the next video.